Question number 2. A scientist cooled the air inside a container. 2.1 is an AO2 question, and this question is from the particle model and the pressure. The temperature of air changes from 20 degree to 0 degree. We can see here from 20 degrees Celsius to 0 degrees Celsius, the temperature is decreased. The volume of the container of the gas stayed the same. The size of the container in which the gas is present, it doesn't change, it remains same. Explain how the motion of the air molecule causes the pressure in the container to change as the temperature decreases. The question is that how the change in temperature affects the motion of the air molecules and how it will affect the pressure of the gas or the air inside the container. Because the temperature is decreased, therefore the motion of the gas particles or air particles will also reduces, and ultimately the pressure will decrease. Let's see the model answer. The model answer is as the temperature of air decreases, the kinetic energy of the air molecule decreases because the temperature is proportional to kinetic energy of the particles. It means the speed of the particle it reduces or it decreases. If the speed of the particle decreases, it means the particles have very less collisions with each other and on the wall of container. Therefore, there will be less pressure. The number of collisions of the air molecule on the wall of the container per second will decrease because they have less energy, so they will take more time to come back and to hit or collide on the wall of the container. So less collision means less pressure inside the container. 2.2 is an AO2 question, and this question is from the topic of specific latent heat. Air contained water that froze at 0 degree. The change in the internal energy of the water as it froze was 0.7 kilojoules. The specific latent heat of fusion of water is 330 kilojoules per kilogram. Fusion means freezing. Calculate the mass of ice produced because the temperature is reduced. Therefore, the water has changed into ice. So we need to find the mass. Let's see what is given here in the question. We have been given the energy that is 0.7 kilojoules and specific latent heat. It is not specific heat capacity topic. This question is from specific latent heat. So we have been given the value of the specific latent heat of fusion of water, that is 330 kilojoules per kilogram. Both the quantities are in kilojoules. We don't need to convert into joules. If the student want to convert into joules, they can convert the values into joules by multiplying by 1000. Kilo means time by 1000. So the values are given here. Energy is 0.7 kilojoules and specific latent heat value is given 330 kilojoules per kilogram. We need to find the mass of the ice. We know that specific latent heat formula is energy is equal to mass into L. We know that energy is given 0.7, mass of the ice is unknown, and the value of L is 330. We need to rearrange it 0.7 over 330. And when we use a calculator, the answer is 0.0021 kilogram. The answer is 0.0021 kilogram. 2.3 is an AO3 question. The student need to use the data, the given information, and analyze the table which is given below. The air also contained oxygen, nitrogen, and carbon dioxide. This question is from the change of state of matter and the particle model. Oxygen boils at minus 183 degree and freezes at minus 218 degree. Nitrogen boils at minus 195 degree, whereas it freezes at minus 210 degree. Carbon dioxide sublimates at minus 78 degree. Sublimation means changing from the gas form to solid form. The scientists continued to cool the air to temperature of minus 190 degree. The question is, what is the state of each substance at minus 190 degree? Tick one box for each of the row of the table. We have oxygen, nitrogen, carbon dioxide, and three states are given here: solid, liquid, and gas. I elaborated my question. Boils mean that it is in the liquid form and it changes from liquid to gas form, whereas freezes means it converts into solid form there. Minus 190 degree is lower than this one, but it is higher than this one, whereas minus 190 degree is higher for both of these values. Let's see the answer. Oxygen at minus 190 degree, we have to see the values for the oxygen around minus 190 degree. Minus 190 degree is below than minus 183 and it is higher than minus 218. So it means that it is not in solid form but it is in liquid form. So the correct option is liquid. If we see nitrogen, minus 195 is lower than this value minus 190. Therefore, nitrogen has both the temperature minus 195 and minus 210 are below than 190. So the nitrogen is neither in liquid state nor in solid form, so it is in gas form. Whereas carbon dioxide is converted in solid form at minus 78 degree, whereas minus 190 degree is very low, so it will remain in solid form. 2.4 is an year 1 question, and this question is from the change of state of matter and particle model. The air also contained a small amount of argon, so argon gas. As the temperature of the air decreases, the key information, from 20 degree to minus 190 degree, the argon changed from a gas to liquid, then liquid to solid state. So three states are mentioned: from gas to liquid, then liquid to solid. Explain the changes in the arrangement and the movement of the particles of the argon as the temperature of the air decreased there. So we need to mention two main areas. One is when the gas, the argon gas changes from the gas state to liquid state, and when it changes from liquid state to solid state. We need to consider the temperature, kinetic energy, and potential energy of the particles, because the kinetic energy is related to the movement of the particles and it relates to the temperature of the particles. Let's see the model answer. The model answer is gas to liquid state. When the temperature of the gas argon decreases, the particles slow down, means the movement of the particle is getting less. The internal energy means kinetic energy and potential energy of the particles decreases. It means kinetic energy is less because kinetic energy is related to movement of the particles, because the temperature is directly proportional to the kinetic energy of the particles. As the temperature has reduced, therefore the kinetic energy of the particles within the liquid is getting reduced. As the temperature is reduced, the kinetic energy of the particles in the gas is reducing. Therefore, the particles are getting closer to each other. A force of attraction develops between the particles in the gas. It develops a force of attraction between the particles, and particles come closer to each other in the gas, and the gas changes into the liquid form. Now we are going to discuss the other part. Now we will discuss the movement of the particles within the liquid to solid state. When the temperature of the liquid organ decreases, the particles slow down even more than before. The internal energy means the kinetic energy and the potential energy of the particles in the liquid organ, it decreases because the temperature is directly proportional to the kinetic energy of the particles. As the temperature will decrease, the movement of the particle will reduce. It means they have less speed. So as the speed is less, therefore the kinetic energy of the particle will decrease. We know that kinetic energy that is equal to half mv square. As the particles are getting slow, therefore the particles get closer to each other. A strong force of attraction develops between the particles within the liquid, and the particles are going to attract each other with a stronger force, and they are coming together in the fixed position. So no free movements takes place. As a result, the liquid changes into the solid. So the force of attraction builds up between the particles, bring the particles close to each other at the fixed position. Therefore, the liquid organ changes into solid organ. The student need to remember one important point there. The movement of the particles in the liquid is slow than the gas but in random direction. But this movement is higher as compared to solid.